welcome to Cherry Pie Math. This video is going to go over representing categorical data. The methods that I'm going to show are not limited to categorical data. They're limited to discrete data, I guess, but we're going to be mainly focusing on categorical data. So here is a picture. It's actually called a pictograph, and I want you to just pause the video and look at it and see what you get out of this. Okay, so hopefully you paused it and kind of looked at it. If not, you probably are able to tell, like, oh, look, there are 4 ice cream cones on chocolate. That's more than the other ones. And obviously there's the title there, favorite ice cream flavor. And so this is a diagram that shows how many people voted for a specific type of ice cream flavor as their favorite. And this is visual representations of data are super helpful because not only do we need those numbers to show like what's the mean, median, and mode, but if we can't use numbers, or even if we can use numbers, that visual helps us to understand what's called the distribution. How did people, or how did, I guess, the data points react to each of the different options? And it helps us see more of a pattern, not just where the center is or what's the most popular option, but it also helps us see what's called the spread. So there's 2 types of data. One is called categorical or qualitative, and the other one is numerical or quantitative. Categorical or qualitative is data that is objects, I guess. Whereas numerical quantitative is data that are numbers. And I put that in quotation marks because there is like sometimes overlap. Like let's say you go to a restaurant and it says, how was your experience from a scale of 1 to 5? That one's kind of weird because the answers are numerical, but like it's kind of quantitative. It's kind of more categorical. So they both meet in what's called discrete data. Discrete data is things that have no overlap. There's no in-betweens. So in the graph before, this doesn't have any numbers. It just says chocolate, vanilla, strawberry, mint, sorbet. So this would be categorical, because it is just objects. It's things that aren't numbers. Categorical data is often represented in dot plots and bar charts. There's actually a couple more ways you can do it. I'm not going to go over it, but pie charts is another one that you might see. Personally, I don't like pie charts. I know they look really cool when you're doing a presentation, but do you know how annoying it is to like interpret a pie chart? Like, normally you'll see like one thing that's like super big and then all the rest of them are just slivers, right? Dot plots and bar charts I think are more helpful just because you can see all of the options a little bit better. But that's just me. Okay, so let's say we have this survey of how you get to school. So we have homeschooling, bus, car, and walking. And I think those are our 4 options. So first, let's make a dot plot, and I have 4 options. So I'm going to have homeschool. I'm just going to write home. I have bus, I have car, and I have walking. And then the way a dot plot works is you just put 1 dot for each data point. So like the homeschool, I start with that one. Here's a dot. And then I have bus. Then I have car. Then I have another bus. Then I have another car. Notice how I'm keeping them level. I do want them to be able to stay around the same spot just so I can compare them a little bit easier. Then I have a walk. And I have 2 more walks actually. And I have a bus and a car, another homeschool, and another bus. Okay, so there's my bar chart. I can easily see what the distribution is. Most people take the bus, but there's kind of an even distribution there. Sometimes we use pictures instead of dots like we did at the beginning. Those are just called pictographs. They mean exactly the same thing. It just means that you use pictures instead of dots. Bar charts are very similar, but instead of having dots, you have bars. And these ones are nice because you don't have to count them as much. So like this would be 0. Actually, I need another line. So let me do this again. Okay. So I I know that the most amount of things I'm going to need is 4 dots and plus this line at the bottom. So I'm actually going to need 5 lines. So 1, 2, 3, 4, 5. I start with 0 at the bottom. And the nice thing about bar charts is depending on your needs, you can change it. Like let's say you have 100 people, you don't want to draw 100 lines. So instead you kind of group it by like maybe 20 at a time. So each of those lines represents 20. And then we still have home, we have bus, we have car, and we have walking. And then the same idea, you just kind of go up to where it needs to go and then you color it in. So here's home, bus went all the way to 4. Car had 3. And walking had 3. And that's really the only difference. Dot plots are just individual points. Bar graphs are able to see kind of, you write out the numbers, so it's easier to keep track of it that way. Different occasions call for different graphs. I honestly feel fine with both of them. Dot plots are a little bit more annoying when you're reading them just because you have to count the amount of dots, but it's really handy at seeing all of that pattern, whereas with bar graphs it's a little bit harder to see the different like positions because there's so many lines, but it is easier to see the number. So it kind of just depends on what you prefer. So let's visually compare some data. So I guess you can probably figure out where I went to college. But we have different heights. And so we have 4'11", and we go all the way up to, what was it in the next one? I think it goes up to 6'3". So I'm going to just be writing stuff down. I'll speed up the video a little bit so you can see, but I want you to pause it and try to do this yourself as well. Okay, so hopefully yours turned out a little bit like this, and you can see very clearly that the data is in 2 different spots. We have kind of a similar spread, like this one has more like a bell-ish shape, and this one's a little bit more uniform, and I think that's mostly because we have less data points for the women's basketball heights. But even with the lesser amount of heights or given to us, we can clearly see that the mean, or the middle of this, which is probably going to be around here-ish, is much higher than the mean here, which would be around there. None of these have really any outliers. None of these are super far away that they would be unrealistic. Maybe a 4'11" in this, like the women's basketball, would be a little bit unrealistic in terms of this data set. I'm not saying if you're 4'11" you can't play basketball. You can totally do that. I'm just saying in my data set here. So one nice thing about visually comparing the data is it's really easy to see kind of where these numbers lie. Like when you look at all of these, you're like, oh my gosh, that's a lot of numbers. But then looking at this, you're like, oh, obviously all of these are lower. Obviously all of these are higher, and you can compare those data. So that's something that's really helpful. And so I want you to kind of think about why that happened. Why is that there's such a big difference, and that we were able to notice that when we drew the picture. So some things to remember is that we can use dot plots and bar charts to visually represent discrete data. And I say discrete because this is actually not categorical data. This is quantitative. Because they all are numbers, but they were all discrete. There wasn't any overlap. You weren't like, they didn't, in this particular data set, they didn't say 4'11" and 3/4. They just said 4'11". So we could use it as discrete data. If it was continuous data, then it would be something different, and I'll go over that in another video. Visual representations help us to compare those measures of center super easily, because each point represents one value, and you're kind of able to stack them. And that applies to both categorical and quantitative data. But yeah, I hope that was able to help you introduce how to draw discrete data, how to draw dot plots, and how to draw bar charts or bar graphs. Okay, good luck.